Hey everyone, welcome back to the Astrophotography Podcast. My name's Steven from Ontario Telescopes and Accessories, and today I have a fantastic guest with me, right, all the way from Kuwait. Again, we are an international podcast after all, right? It's Jasem from Ikarus Technologies. Jasem, is that correct? Ikarus Technologies?
That is correct.
That's correct. All right, I want to make sure. And they put out Stellarmate, the operating system, and also the hardware that goes with it. Now, Stellarmate might be new to a lot of people. There might be people out there that know exactly what I'm talking about, but Stellarmate is an operating system and a hardware platform that will allow you to do astrophotography with all your hardware. And when I mean all your hardware and your equipment, it could be ZWO, QHY, Pegasus Astro. It doesn't matter the manufacturer. There's probably a driver for it, and it's got fantastic support, and it's a fantastic community. So, Jasem, welcome to the Astrophotography Podcast, and I appreciate you taking the time today. I can see the red light there. You must be imaging, because I know it's late in the evening for you compared to middle of the day for myself.
Thank you, Steve. I'm glad to be here. And yeah, I think my webcam has this red tint, and I am technically imaging now. I'm prepping up the observatory.
You must have a clear night, which I can't say I've had a clear night in the past few days. Anyways, it's been cloudy. Plus, we have the moon right now too, so it doesn't help with my one-shot color camera, which I should probably change out to a mono so I can use it more. But thanks again for joining us. And Stellarmate's been around for a number of years, right? Off camera, we were talking about it a little bit, and I said I had started dabbling with it good 4 or 5 years ago. But tell us a little bit more about Stellarmate. When did it start? Why did it start? What prompted you to create this new system?
I guess the history goes all the way back to my college year in the US. I did computer engineering at the University of Kansas. That was back in the early 2000s, and so I took computer engineering. That was my major, and then I took astronomy as a minor. And I guess from then, this is where I started dabbling with controlling some telescopes. I had Meade LX90 telescope back then, and I was already part of the KStars team. I joined them in 2000. So around 2003, I really wanted to integrate control the Meade telescope from KStars, and this is where I started. And then eventually in 2003, I joined another project called INDI. It was just starting up, which is this control protocol developed by Elwood Downey. And it was just in its infancy. And then I really joined at the right time to shape it up and make it what it is today. And so let's say from 2003 up until 2017, I was maintainer of both ND and KStars, which is the desktop planetarium software. So the Raspberry Pi 1 came out, and then I was like, okay, well, up until that point, if you think using Stellarmate is hard, up until that point, it would be very, very challenging to use Stellarmate unless you're some sort of a Linux guru. You know how to compile stuff, and
Right.
you know how to set up a complete system. It was truly only within the realms of the Uber geeks. It wasn't available to everybody, let's say that.
I remember the Raspberry Pi 1. I had a few of them just to tinker around with, and I think they came out around 2012, 2013. Around then, had the RCA port on the side for audio, and they didn't have a lot of memory on them, if I remember correctly. They were very, very basic at the time, but very popular when they came out too. Right? They became very difficult to purchase because a lot of tinkerers got their hands on them for various projects and fun.
So around 2017, I think by then we had the Raspberry Pi 3.
Mm-hmm.
And this is where I thought, well, why don't I just package everything together and try to make it easier, at least to use KStars and INDI. There was no Stellarmate app to speak of back then. There was, like, I will call it a pseudo app where you just it's like almost it's glorified like about page. It
Right.
didn't have any functionality back then. And so this is where I started it. And in 2019, actually, Ikarus Technologies was made. So Stellarmate predates the company that
Yep.
manages it now. And then in 2020, we wanted to release. Actually, it started in 2019. We wanted to release Stellarmate Pro, and of course, we were hit with you know uh, the events in 2020,
Yeah.
and then all the supply chain issues that resulted from that. And we got really stuck, especially since we were unfortunately reliant on the CM4 by Raspberry Pi, which is the Compute Modulo 4,
Right.
as basis for our board.
Mhm.
And we couldn't really get any components up until like late 2023. This
Okay.
is where we started to get our components. And so yeah, this is just like a short history of the Stellarmate project.
Yeah. The Stellarmate software, it has evolved. Now, you mentioned before, in the early days, you'd have to be a Linux guru to really set it up. So to stand up a system, to install the software, and to get it going. But now with the Stellarmate package, the original one on the Raspberry Pi, the Stellarmate Pro, the Stellarmate X, right? It's turnkey, open the box, plug in your hardware, connect
Right.
the app, and you have a complete full app that works with it too. That works on a tablet, right? Oh, and you can control everything. So you're not actually interfacing directly with EKOS. You are in another environment that will interface with EKOS. Is that correct?
So Stellarmate app is another scan for EKOS. Um, that's what it is for the most part. It's another interface for EKOS. Everything eventually happens in EKOS, and this is by design because most of the work by not just me, by the whole KStars teams, goes into KStars and EKOS. So we wanted to preserve EKOS as the core system. So as it evolves, as it improves, so does Stellarmate and all other clients actually, not just
Sure.
Stellarmate.
Yeah. So how many people, like, how big is the team then that works on this? When you say the EKOS team, is it you and somebody else? Is it a room full of people?
Right. So it's a pretty small team. So the core developers for the software are two. It's me and another person,
Okay.
another engineer. For the hardware, we have also another dedicated engineer. And now we just brought in more people in our team to work on, EKOS Live and Stella, which is this is our next step in the evolution of this of addressing this platform. So right now, today, we for everything related to Stellarmate and its ecosystem, we're talking about 5 people.
Oh, that's amazing. Stella, I want to talk about Stella because about a month ago, I'd say, you put a video out on Facebook. That's where I saw it. And my jaw literally dropped when I saw the demonstration of what it was capable of doing. And I couldn't stop talking about it when customers walked into my shop or my friends, or people I didn't even really know all that well, but were into that are into astrophotography. And I said, you got to check this out, right? And there was a lot of disbelief at first, and I showed them the video, and their minds were just blown, right? But so we'll talk about that in a bit. But I want to talk about Stellarmate a little bit more in terms of remote systems. And for myself, I'm all about remote. I like the idea of having that remote capability. My remote system's in my backyard, so when it's really cold in the middle of February, like minus 30 degrees Celsius, I don't like to be outside. So
Makes sense.
I consider that remote. And then, we were talking earlier off camera, and it's what, 41, 42 degrees Fahrenheit, Celsius for you right now, right? And
Right.
yeah, it's about 38 degrees Celsius right now where I am. We're going through a heat wave ourselves. And again, I don't like to be outside. So let's talk about remote, where we can set up Stellarmate locally at our equipment, and then be able to remote to it. Can we have multiple Stellarmate systems going? Could we have like and then be able to interface to it from one location, like multiple ones?
This is very interesting because I discussed this with my team today. So through
Fantastic.
EKOS Live, not through EKOS, through EKOS Live, which is this our online platform, we have this idea of instance selector. So EKOS Live, if you're if somebody is not aware of it, it's almost EKOS interface but online, web based. So you
Yep.
can do everything what you can do with EKOS, but you don't need to download any software. You can
Yep.
simply go to ekoslive.com, and it's, by the way, completely free. We have free tier, and then we have the pro tier. And so the free tier, you can completely use it and control your Stellarmate remotely from there. And in that one, in case you have multiple observatories, or let's say multiple KStars or multiple Stellarmates running, you go there and then you get to select which one you want to be controlling right now.
Oh, wow.
Right? So you select it, and then everything becomes connected to that one. You can go back and then switch to another one. And the nice thing is, because everything is running on the unit, there is no discontinuity. You just keep going. Let's say, for example, you're running focus algorithm on unit 1 and guiding on unit 2. If you switch back and forth, everything is going smoothly as it should be in each unit. Because the interface is just like, let's say, again, it's a skin. It's a front end to EKOS, which is running at the background.
Yeah, Stellarmate's running locally. It's doing its thing. You've given it its sequence. It's imaging, right? And then the EKOS Live is just simply connecting to it and showing the data and giving you the control if you need to make control
Right.
change. That's all it is, right?
Exactly. And the system has been designed from the ground up to be to support remote control. So it's not like as a hacked solution that comes later. This is like built in from the start.
Oh,
And the nice
fantastic.
thing about it is that you can concurrently use the app to monitor your Stellarmate, and then use, EKOS Live from a browser if you want to. And at the same time, you can also like use a VNC if you want to go and check in. You can do this simultaneously at the same time. So there are, and not only that, there is a fourth method. Like if you're on a PC on Mac, you can actually use KStars on your system to remotely control your Stellarmate unit. So there are multiple ways of controlling unit, which I think is probably unique to Stellarmate. It's not available to other solutions.
That is very unique, and I think it's very powerful as well to be able to have a cross-platform, multi-platform interface that will work with Stellarmate. So that no matter where you are or what hardware you're on, you can connect to your equipment. And I think if you want to connect to something remotely, there's a lot of power to that as well, right? So I can't think of any other system out there that allows you to do that seamlessly from one platform to the other, or even simultaneously. That nothing really comes to mind.
I mean, there are other systems that you could do, but you have to use third-party software. And something we were proud of that we mentioned in if you go to summer.com, we say we give you a solution and nothing else is required. You don't need to install any additional third-party software. Now we support some third-party software, we support some integrations, but like nothing is required from the get-go.
Okay, well, out of the box and away you go. That's fantastic.
Right.
Oh, okay, so let's say we have a brand new Stellarmate Pro, right? And we want to set it up, right? Can you walk us through that? Can you share your screen, because we were looking at something earlier off camera. We want to set up Stellarmate and go through the paces of getting something going. How would we do that? And if you're listening to this podcast through the audio, through a podcast platform like Spotify or Apple Podcast, or right on SoundCloud where we host, I encourage you to go to our YouTube channel and watch along. This video will be for you to watch, and you can see how everything's going. But we'll try to describe what's happening at the same time.
Here, I just shared my screen. So this is a cast of my Samsung tablet. And usually, I mean, here, usually on the left side, you see the detected Stellarmate devices. Usually, you would have only one, right? We're talking, most people would only see one, but I have here like multiples because I'm like testing, multiple versions. And here I will also show, this is EKOS Live online, so ekoslive.com.
To the website,
right? Yeah, this is the website. And here I'm also like selecting, for example, the observatory. And this is the actual, this is a webcast of my roll of roof here. This is my own home observatory. It's not in the backyard here. Here we have them on the roof, right? So I just built this on the roof.
Oh,
so
yeah.
So usually, people you would start with creating an equipment profile. So let me just edit this profile so you can just see, but it's the same operation. So you would select your mount, you would select your camera. You would see it here, like from the list of available cameras. So usually we have camera 1 and camera 2. You can actually add additional cameras in the auxiliary list here. And then, of course, you would add, if you have any focusers, any filter wheels, adaptive optics, any dome or roll-off controllers. Now, I didn't select one here. The reason is I already have my dome controller connected to another Stellarmate in my observatory. So I have two Stellarmates changed together, and one is responsible for the dome and the weather station that is chained to my Stellarmate Pro. So Stellarmate Pro is the master, and there is like another Stellarmate that is dedicated to running the roof controller. So, and here I have Primalus Labs Alto and Giotto. I'm not sure if I'm pronouncing these right, but these are the flat panel and the mechanized dust cap.
Sure.
And yeah, so usually you do this, and the first time you would run it, and in the recent version we also added advanced options. This is if you wanna like for example, select PhD2 as your guider, for example, or have more guidings. Here you can see, like in the remote drivers, I selected something called Ikarus Spy, which is my other Stellarmate running the roof controller, right?
Okay.
So usually the first time you would like run this, you would go to the port selector, and if you have any serial devices, right? So if you click this little like chip icon here, here you would see a view of the detected USB devices on your system, and if it's some of them are recognized. So here, like Starlight Express CCD, and then here it says it detected 3 serial devices, right?
Yep.
And then of course you would go and find out, what is the serial device for. And just like Windows, where you select COM1, COM2, COM3, here if you start the profile, and if you're for the first time, you need to do this port selector. You need to say, well, I have EQ mod and it's connected to this port. I have Nightcrawler, and it's connected to this port.
Okay.
So this is the first thing, and then after that, you go and do the optical train.
Right.
So actually, let's go ahead and start this. In here, there is also a new feature for the power. Here it says that power is in sleep mode. The new feature is that you can have it. You can have Stellarmate automatically turn on the power, and whenever you stop it, it automatically turns off the power, and it will remember this. This is not the default mode. The default mode is you manually control the power whenever you want to on or off. But we have some people that says, sometimes I run the scheduler, and the scheduler sometimes goes into sleep mode, because the target is not available yet, and it can go for sleep mode for a few hours. And during these few hours, I don't want my equipment to be running, and I want them to be off, the power to be off. And whenever it starts again, then I want them to be, powered.
Okay.
So this was added just recently. Yeah.
And you're referring to the power that's on the Stellarmate Pro. The Stellarmate Pro has power ports on it to supply power to various pieces of equipment.
Correct. Yeah. So we have four 12 volt DC, two do heaters. Here you see now it started the 4 ports, right?
Mm-hmm.
And then one with variable voltage output.
Okay.
Right.
Yep.
Another thing you would do, we have this concept called of optical trains. Okay, so here it says that reported a missing device, which usually happens. I have an issue with my QHI filter wheel. The USB itself actually was damaged long ago, and I wasn't able, because it's connected to the camera, the QHI filter wheel, and I was never able to replace that. But here usually we have this concept of optical trains, which is simply how your different devices are arranged, right?
Sure. Yep.
So you select, okay, so for my primary optical train, and usually this was your imaging train, right? You select the mount. Here, for example, we select what is the light box, what is your scope, right? Or lens, DSLR lens, what is the rotator, the filter wheel, etc. So after, and then, and usually the guide, you select the guide camera. So in the guide, like I don't have a light box, it doesn't make sense to use a light box or a rotator or other devices. And you select the camera and you select how you want to guide via. So if you're using an ST4 cable between the camera and your mount, then you would select, the lodestar in my example as the guide via, right?
Yep.
But if you're sending pulses directly to the mount, you would be using this.
Yep.
And here, of course, I have the guide scope selected. Yep. And so after this, you can go to EKOS. So we have this EKOS interface, and here, so on the top here, we have the rotator control, right?
Okay.
And then we have the quick capture modulo, which is this is to quickly capture like a preview. Here you can put some parameters to capture. So let's say 2x2, and I'm just I'll click capture now.
I like that you have a rotator control in your app. The interface is very well laid out. You can see the type of equipment you want to control from the top, right? And then the controls off to the side on the right.
So I'm running the debug version of the app on my system. So the debug version is like 10 times slower than the production version, which everybody uses. So it took a while to do the capture. But yeah, usually on the release version in the app stores, it's pretty quick.
Okay.
And here you have the quick mount controls where you can see, you select the speed, you can do parking, you can toggle tracking and everything.
Okay.
And yeah, here we have these quick controls for focus, right?
Okay.
For alignment or regular just alignment if you do a go-to. So usually, and then here you have the sequencer. So here where you can add presets, right?
Yep.
And select, all kind of different parameters for your presets. And then after you save them, you just put the count and click add to sequence, and then you can add a sequence. Just before that is, I want to show that this one is where you have your observatory control. Right now it's limited to the cab control and the dome control.
Okay.
And I don't know why the cab is it's supposed to be parked, actually, not unparked. It's good to know. And for example, now in my observatory, if I want to control it, I would just simply click unpark here,
Okay.
And it's probably slow to respond because it's running this debug version. And let me do that. And then if we go here,
Oh yeah.
here you can see the roof is pulling back. And actually, if we come here, look at this. Everything is on EKOS Live online. We have the same image here, right? This is the web interface. We can even see the same operations that are happening exactly using just a web interface. So you don't have to have any software.
Yeah. The whole interface between EKOS Live online and then on the app seems very consistent between the two. So if you use one or the other, I'm assuming it looks like very seamless, and
Right.
it should be able to go back and forth without any problems. So, my first impression from seeing this is being able to go and set up your equipment really quickly, set up your sequence, and then start imaging, and it'll do everything for you that you set up in your sequence. Planetarium information, object information, it's in there as well. So you can, oh, that's fantastic. Yeah, it's right there.
Right.
Yep.
So you usually have two options. Either you go to Targets tab,
Okay.
which exists on both here and EKOS Live online, and Planetarium. So Planetarium does not exist on EKOS Live online yet, but we are working on it. So you can either do this or find like suitable targets, and these are and here you can see the view that you would be able to capture. So
fantastic.
This is your frame.
Yep.
And so actually, since this is not the galaxy season now, this is I think like globular cluster season nowadays. So here we have M12, and here that says right now. I mean, the yellow line means now. Right now, the azimuth is 134 and the altitude is 50. So this sounds pretty good target to image. Yep. And then what I would do usually is I just go, go and solve. And then if you go back here to observatory, you can see the mount, rotating to this object. Usually it will capture a couple of images in order to center it. And if we go to sky, if you click this here lock button here, it will always track your mount.
Okay.
So here you can see where the mount is in the sky. And if you go to EKOS and if we go click on the alignment, we can even see the alignment in, it's in progress.
So we're just going to be taking the pictures and then plate solve itself to the correct position.
Yeah, exactly. And so it usually needs like 2 to 3 iterations to do that. And then you see here like there is a yellow rectangle over your target, and usually this turns to green. Oh, there we go. So this is right now. And so one nice thing also is that we have this framing assistant here. So if you click on the image here, this orange line here, this designates the top of your frame. So if you were to capture an image, we would say like the star to the, let's say, bottom right of your image.
Okay.
And here what you could do is you can actually like here it's going to be pretty slow because this is debugging it, but here you separate it from like this where you are versus where you want to be, and this way you can actually you change your position angle to whatever position angle you desire.
Okay.
Now, since I have a rotator built in, you can just leave it to automatic, and you just can simply click go on rotate.
Okay.
And actually, you know what? Let's do this here. So let me click go on rotate. So the center changed slightly because I dragged it right there.
Frame. Yep.
Yeah. So what it will do is it will go there, and it should then plate solve, rotate, and then plate solves again. And the goal is for this angular offset to become 0, right? For this square, there we go.
There we go.
Yeah.
Yep, perfect.
Yeah, so it's done. So now the 2 square match, and if we were taking an image with this setup here, then we should be expecting exactly where it should be as per the target. So the target says it would look like this, right?
That's
And
what we
if we
should get.
capture it, and then here also we can also start guiding. So guiding is pretty easy. Here you have the quick controls, like
Okay.
if you want to set the gain, the delay, the exposure time.
And this is
So let's
using
set it to
guiding.
seconds.
This is using guiding that's built into Stellarmate. This is the built-in.
Right.
There's
Yeah,
no
this is the built-in guider.
there's no need to use like PhD2, but you could if you wanted to.
Yes.
Okay.
So BHD2 is supported. Uh, uh, it's not supported where it's as transparent to use as this one. There is a little bit of setup involved. Now we're making this easier with every release. Now at least you can select from the profile that you want BHD2, and it would actually start up BHD2 and it would connect to it. But there is some initial setup with BHD2 that you need to do manually. It's
Sure.
not handled by the app.
Yep.
But once that's done manually, it's only needed once.
Okay.
Once that's done, then here we have the summary view, and where you get to see. So I have a little bit of high RMS today, and but okay, let's capture 30-second exposure here.
So if you were to set up PhD2 that one time, I'm assuming it's setting up what your guide camera is, the focal length of your guide scope, the type of mount, the interface. That is really no different, I would assume, from setting up PhD2 the first time on like a Windows machine.
Right. Yeah, it's exactly what it is. You just need to take the usual steps required to set up PhD2, and next time you start it up, or it gets started up by the app, then it just loads up whatever previous settings that you had.
Okay. So, you've taken us through a really good rundown of setting up Stellarmate for the first time, using the internal guider, using the different controls around, very intuitive, very straightforward. If you have a rotator, framing up your object. But the exciting part for me is Stella. Let's talk about Stella a little bit.
All right.
What it can do, because when I saw this, I was just floored with its ability to take in, I don't want to say commands, but just talking with it, saying, "Oh, this is what I want to do, and image this, and these are the filters I have," and away it goes. I hope I hope I'm right with that. I'm just going back to the video, but yeah, walk us through Stella and give us a little bit of what it's capable of.
We're integrating it with Stellarmate app. It's not exactly ready inside Stellarmate app, but it is available in EKOS Live. So in EKOS Live, we have the Stellarmate beta, and usually what you do is we wanted to make it easy so that you use natural language to command your sequences and your scheduling as well. We can, for example, tell it to capture 5 images, each one is 60 seconds long.
That's great. Yeah.
2x2,
Yeah.
pinning 2x2. Now, I don't know. So this one is still beta, but let's say capture 5 frames, each 60 seconds long at 2x2 binning. Okay, that's it. We're done. So
it's like that.
Yeah, it's pretty amazing when it works, right? So this is why it's still in beta. It doesn't work all the time. But it's pretty amazing. So it got us this, and so what's happening here is that we need to confirm this by clicking execute next. Okay. And so let's do this. Let's say execute.
It's starting the capture, and that's it. Yes, and, so can I tell it to image an object? Let's say the Crescent Nebula, and for when it's above a certain elevation, so when it's above 40 degrees, and I want 3-minute exposures in hydrogen alpha, and then take corresponding flats and darks and so on, it will do just that.
We can do this. I don't know if we can do it with voice, but we can.
Let's type it in. Let's type it in.
Okay, so schedule a crescent nebula when it is above, did you say what? How many degrees?
40 degrees.
40 degrees and capture, um,
3-minute exposures
okay, 3 minutes exposures.
in hydrogen alpha.
And okay, okay, or let's say hydrogen alpha.
Yeah. I guess we need to tell it how many exposures, right? Um, so
Yes.
we'll say let's say 20 3-minute exposures.
Okay, 20 3-minute exposures in hydrogen alpha. All
Yep.
right, that's it.
And can we tell it to do darks and flats and as well?
Okay, and then after that, capture darks and flats. Okay, so this is interesting. I never tried this before, this combination. And so let's see what it does. So now we're sending this. And it says, okay, when the Crescent Nebula is above 40, capture 23-minute exposure hydrogen alpha. After that, capture dark flats. Now, just to be sure, I need to check the XML to
Okay.
see, because this is generated XML. So here we see hydrogen alpha, and notice that it selected the filter that I have defined.
Yes. Yep.
It was able to tell this. The count is 20, right? And so this is the first job, right?
Okay. Yep.
Now this second job is to capture dark. Now it says here the filter is R, but it doesn't matter if you're doing dark,
Yep.
right? Now the third one is where it might not be working. Let me see. So yeah, so this one is actually incorrect
Okay.
because the filter is supposed to be hydrogen alpha,
Okay.
not red, because you need to capture this. So this is something we'll definitely be working on. But in principle, and this is the third job, in principle, it understood what
Yeah.
what you meant, and
I can,
it executed that. You can even tell it to do dark flats in addition to the flats. And
okay.
so with dark flats, it will capture the flats, figure out the exposure required for them to achieve that specific ADU, and
Yep.
then capture the darks accordingly.
Okay.
Yeah, I
So
would do that.
with this, can we give it like specific dates and times to do things? Can we tell it to look at a past image and to read the FITS header, to use the same exposure times and angle of the exposure as well? Can it do that? Is that what the plan is for it?
Yes. So the idea here, you see here this attachment
Mhm.
button here. So what you can do, you can attach an image of a previous target, and then you can tell it, well, you can tell it, please identify the targets in this image. And so it will blade solve it essentially, and then figure out what the kind of targets in there.
Right.
But then what you could do is you could say, use this image, because in the scheduler, like if you check KStars, in the scheduler, we have this option to specify a FITS file, right?
Okay.
And so let's say, for example, a Crescent Nebula. Here you can specify the Crescent Nebula, but essentially the FITS file decides the exact framing that is required.
Okay.
So KStars will only image after the position angle, and the exact center for that FITS file is achieved within tolerance,
Right.
right? And then it would take that. So actually, most of the heavy lifting is done by EKOS. It's just like we need to figure out how to fill this field from EKOS Live, right? That's the
Right.
trick, is to be able to attach this image. This one says FITS, but it could be JPEG. Actually, it doesn't need to be FITS exactly. And yeah, so we could do that. Now I'm not sure if we now I think if we capture and if we attach an image now, right now I think we can only tell it to solve it and give us the images,
Okay.
but to use it as in a capture, I don't think this is right now supported, but we're working on it.
That's fantastic. It's just even having the ability to naturally speak to your equipment and and tell it exactly what you want it to do, I think is absolutely amazing. Um, and like I said, when I first heard about this, my jaw dropped when I saw the demonstration that you had done for it. I thought it was just absolutely amazing. But I'm sure it'll continue to get better. Like I said, adding in those features, and when it's out of beta and
Right.
release, I think it'll be very very exciting. Tell me, if you were dropped off on a desert island. I'm asking everybody this. All right, all right.
I'm going to one tomorrow, actually.
Oh, okay. All right. Okay. Okay. All right. Okay. So you know what? We're not going to be because you live in a very hot environment, anyways, right?
Right.
We're not going to put you in a desert island. We're going to put you up in the Canadian tundra, right?
All
Where
right.
there's still nothing there, but you have everything you need to survive and live very comfortably, right? And you have your
Right.
favorite astronomy equipment with you, imaging equipment, but you can only image one target for the entire time that you're there and nothing else until the time that you're rescued, right? What would that target be? What is your all-time favorite image target that you'll image over and over again and never get bored of?
That's a very interesting question. I would say that I know the Arabic name for this target. I'm just trying to remember the English name. Um, what is it called? It's a famous nebula that I think everybody on Earth imaged, but I still can never get bored to it. Um,
Does it
let
have a
me let me let yeah
number?
let me look up the Arabic name, and then let's see what is it in English, because I just my mind has this blocked. So Sadim, it's called Sadim al Warda, right? In and Rosette Nebula. Oh, there we go. Okay.
Rosette Nebula?
So Rosette Nebula is probably, it is because this is actually, I bought my first astrophotography equipment back in 2010,
Okay.
and so I didn't say this. Was uh, 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 so how EKOS was started. EKOS was started because I bought a bunch of equipment for almost $10,000. I bought a QSI camera. That was my first astrophotography camera. And then I got Skywatcher EQ5
Okay.
back then, and I had all of this equipment, and I wanted to use KStars, and so KStars has INDI drivers, but it didn't have anything that is used for sequencing, for focusing, for guiding.
Right.
And this is the time. Not in 2010. It was by 2012. I was like, okay, I need to start using this in Linux, using the system that I love to use, right?
Right.
Or rather, what people say, eat your own dog food, right? So
Yep.
I'm using KStars, I'm using INDI, I have the drivers,
Yep.
but there is nothing that controls it. So this is where KStars EKOS was born. EKOS was
Okay.
born so that I can control this equipment. And I remember the first target, deep sky target, was the Rosette Nebula,
Okay.
and it's been my favorite since then.
That's a fantastic story with it. I haven't I've yet to capture that target. It's not the easiest for me, and where my equipment's located. Um, but there is a feature within the Rosette that I really like, and whenever I see, I was talking to Pegasus a few weeks ago, and Evans said the same target. But whenever I see the Rosette, I always look for one specific feature, and I call it the cosmic wrench. And it's this little small area of cloud, right, of gas, and it looks like a wrench. And
Okay.
it's one of those things. I think it's really cool. The Rosette's a really nice target. Do you prefer to image it in uh, color or in narrowband? Do you have a palette that you like to use? Have you done all of that?
Right. So I'm living in Portal 9. So it's narrowband all the way,
Yeah.
right? Um, I think here we have this really nice feature in KStars, which is this sub exposure calculator,
Okay.
which
Yep.
is you give it your camera, you specify the portal, scale that you are in, the scene conditions, everything, and it gives you, the optimal. This is heatedly debated, but the optimal sub-exposure if you
Nice.
want to image. And here, with using a one-shot camera, you can get saturated in about like 60 seconds or even less.
Yeah.
So it's really terrible, which means also that even with using some of these light pollution filters, I tried that. I tried to use light pollution. It improves the situation, but only to a certain extent. And the only way to get any really nice images is to just do narrowband
Oh man.
imaging.
Yeah. Bortle 9. You might as well be living in a flashlight. Bortle 9. That's amazing. I have a lot of respect for people that image in such harsh light pollution conditions. Um, it's I'm sure it could be a real challenge. But yeah, narrowband is the proper way to go for that. So Jasem, I really appreciate your time and the demonstration that you gave us with EKOS Live and the Stellarmate app and how to get things going with it. It's a fantastic system. I encourage everybody who's listening to give it a shot. Take a look at it at least. If you have a mix of equipment, you want to get away from a Windows environment, you want to get into another operating system, another way of managing your equipment. You want to get into AI using Stella, which I still think is one of the most amazing things I've seen. This is a total game changer, I think, to astrophotography. We talk about, well, what's next? What's new? This is new, right? We've talked about AI in the past, in other episodes, but this is integration of AI and natural language speaking to computer in such a productive manner. I think it's fantastic. So congratulations, Justin, to you and your team for developing that. So thank you again for being with us today on the Astrophotography podcast and sharing everything that you have with Stellarmate and the overall system and how it works.
All right. Thank you, Steve. Glad to be here. Thank you for this presentation.
Oh, you're more than welcome. Clear skies, everyone. Thanks for joining, and be sure to like and subscribe, and we will see you on the next podcast.